Welcome, ladies and gentlemen, to the Free Response Question Review. In today's episode, we will be discussing the 2012 Calculus BC exam, question number 3 from the non-calculator portion. This question also made a guest appearance on the Calculus AB exam of that year. It's a standard graph of f function where f is not what you think it is. It reads, let f be the continuous function defined on -4 to 3, whose graph consists of 3 line segments and a semicircle at the origin. And it's given above. Let g be the function defined by g of x is equal to the integral from 1 to x of f of t dt. Now, a minute ago I mentioned that f is not what you think it is, and that's true. This is a classic graph that's the derivative of something else. So one of the first things you want to establish is that what has to happen to f in order for f to become g is the integration of f creates g. And the reason why that's important is because if you know that the integration of f creates g, then you should be able to reverse engineer the idea to say then that the derivative of g would get you f. Meaning, this graph of f is really a graph of g prime. And that should influence every single answer that asks you about g in this problem. So please make sure you keep that in mind. One other thing. Just because we established the relationship between f and g prime here doesn't mean that we don't have to do it later on in the problem. We will be establishing that relationship a couple more times in the context of this problem here. So let's go and just take care of some of these answers here before we get into too much with our words. We're just going to find g of 2 and g of -2. So g of 2, well, what is that? That's the integral from 1 to 2 of f of t dt. Well, what is that? From 1 to 2, the integral from 1 to 2, that's 1 here, and then 2 here. So that's going to be this triangle right here. So I know that my base is 1, and then my height at that moment in time, well, since the slope here looks like down 1 to the right by 2, that means that the vertical action had to go down 1/2 in order for the horizontal motion to go to the right by 1. So this helps me because now I can say that the area of this triangle will be 1/2 base times height, which will get me -1/4. So just some some geometric manipulation here. We got this under control. G of -2 is going to be the integral from 1 to -2 of f of t dt. Now this is going to be a little more complicated because now we're going to actually going to be going backwards on our integral here. So from here, that means that anything below the x-axis is going to be positive, and anything above the x-axis is going to be negative. So what I've got is I'm going to be adding up a semicircle and this partial triangle right here. So it's going to be this semicircle here, and it's going to be added to a triangle here. So from here, let's go and find out what the individual pieces are. Well, the area of the circle is going to be 1/2 pi r squared. So that's going to be 1 squared. Now again, that guy's going to be positive. And I'm going to add that to 1/2 base. So in this case, the base of the triangle is 1. And the height of the triangle, it goes as far up as 3. But remember, this is going to be a negative value because I'm moving backwards on my interval, making the above x-axis parts negative. We talked about that a few seconds ago. That's going to make this pi over 2 minus 3 over 2. And you can go ahead and close up shop on part A. Alright, cool. I think we're pretty good so far. Part B, it says, for each value of g prime of -3 and g double prime of -3, find the value or state that it does not exist. So g prime of -3, well, remember, part of the reason why we established the relationship between f and g so quickly was so that we could be helped by problems like this. So g prime of 3 is like saying f of 3, because remember, if I derive g once, I arrive at f. So I have to just go to the graph and find out where that is. Well, from here, where is g prime of negative 2? In other words, where is f of negative 2? Well, that's right there. How high is that? Well, that's 2. So I think that's a pretty slam dunk case right there. That's just going to be 2. G double prime of negative 3 is like saying f prime of 3, right? Again, just extending that relationship one more derivative down. Well, f prime is the slope of f. Luckily, the slope at this moment in time is linear. So I can go ahead and use the integrated one version of slope to find out what that value is. So it'll be 3 minus 1 over negative 2 minus negative 4. And you can go ahead and leave it like that if you wanted to. Remember, we're on a time crunch on this AP exam, especially this year. I would not simplify any further than that. But if you're going to check the answer key, you'll find that you get a 2 over 2, which ends up becoming 1. So pretty straight and fast FRQ so far. For part C, I'm going to go and scroll down here. I'm hoping you guys have the problem in front of you because I don't want to keep scrolling up and down and getting people seasick. So we will go ahead and just answer part C down here below. It says find the x-coordinate of each point at which the graph of G has a horizontal tangent line. For each of these points, determine whether G has a relative min, relative max, or neither at the points and justify your answers. Okay. So from here, the first thing you want to establish is establish that relationship. Remember, a few minutes ago, I said that establishing the relationship between f and g in the graphical area is not going to be good enough for you to earn points in every single part. So from here, we want to say g prime equals f. Just establish that from the get, and we'll be okay. So from here, how can we determine if g has a relative min, max, or neither? Well, remember, g will have a relative min, max, or whatever, right? G will have relative extrema when g prime changes sign, when g prime goes from positive to negative or negative to positive. In other words, when f changes sign. So we have two candidates for relative extrema. So again, I'm actually going to scroll up for this one. I know I said I wasn't going to do it, but I'm going to do it anyway. We have two candidates for relative extrema. One, go to forest green right here. One is right here. That is one candidate for an absolute extrema, or for a relative extrema, because g prime or f is changing sign. The other one is right here, kind of, and that's because f or g prime equals 0. Now, they wanted to know where the horizontal tangencies occur. It does happen at those 2 points. Kind of looks like the eyes of a smiley face right there. That was actually on accident, but we'll go ahead and do that. Now I even changed the color of my text right there. Okay, so we established that g prime equals f. I'll go and switch back to yellow. And we can say that g has horizontal tangents at x equals -1 and 1. And we want to justify our answers because g prime equals f equals 0. Now, you didn't have to do the second establishment here. We already established that up here in the forest green. But I'll just be extra thorough. And then I will further state that g has a, well, what does g have? Well, remember, when it comes to -1, g prime is going from a positive value to a negative value. What that means is that g will have a relative max at x equals -1 because g prime goes +2 minus. And then at g equals 1, it looks like they want you to think that it's a local max at g equals 1 because you're apexing and then coming down, but that's not true. Don't fall for it. Remember, the AP exam, it knows what you know, right? It is trained very well. So don't fall for it. G has neither at x equals 1 because g prime does not change sign. So don't fall for the trap. Everyone's going to fall for the trap except for you. All right, let's talk about D. Part D, it says for negative 4 to 3, find all values for x for which the graph of g has a point of inflection and explain your reasoning. Okay, well, for points of inflection, we will use the second derivative. In other words, we will use g double prime. In other words, we will use f prime, or the slope of the graph that we are given, to determine points of inflection. So remember, g double prime or f prime will change signs when we have a point of inflection. So where does that possibly happen? Well, g double prime will change sign. In other words, the derivative of this graph will change sign when the graph itself, and I'll go ahead and switch to this lavender color, even though it's kind of hard to see, it will happen here and here. And that's because the graph changes direction. The slope of the graph changes sign. So all we have to do is just put that down in our notes and reestablish another relationship. So I will go ahead and say that g double prime equals f prime. Again, I am establishing that relationship. That way they know that I am clear on what I know. G double prime equals f, and then I will say g has points of inflection at x equals negative 2 and x equals 1, because g double prime equals f prime changes sign. Now, another justification, I really think that this might be the better one. You might want to say something where g has points of inflection at x equals negative 2 and x equals 1, because g prime equals f changes direction. Either one of those would be fine. I'm more partial to the changing direction. It keeps things closer to the graph in question. It's more of a literal explanation, but honestly, they would take either one as long as you had the established relationship laid out for you. So again, pretty quick and easy FRQ. As always, though, it's easy for me because I've done this a few times. But if you have any questions, please feel free to leave them in the comments section, and we will see you in the next episode.